Hi, today we're going to continue looking at basic terms in geometry. We're going to look at something today called a postulate, which is simply a rule in geometry that cannot be proven. These are very important statements that we will be using throughout the course. First postulate that we're going to look at this year is the segment addition postulate. The segment addition postulate says if point B is between points A and C on a segment, then we take the length of AB and add it to the length of BC, that will equal the length of the entire segment AC. Let's take a look at an algebra problem that shows this. If AB is x and BC is 2x plus 1, and AC, the entire segment, is 25, we can set up an equation to solve for x and find out what the values of AB and BC are. Using the segment addition postulate, we're going to take AB, which is x. We're going to add BC, which is 2x plus 1, and that all equals the entire length, which in this case is 25. We can combine our like terms to get 3x plus 1 equals 25. And using our rules for simplifying, we can subtract 1 and divide by 3 to get x equals 8. We plug that back in for x and 2x plus 1, that means AB here would be 8, and BC would be 2 times 8 plus 1, which would be 17. So x equals 8, BC equals 17. In geometry, when two objects have the same size and shape, they're known as congruent. And there's a symbol for congruent, which is an equal sign with a little squiggly line above it. These two segments are congruent because they have the same length of 3 centimeters. You can mark that segments are congruent on a diagram with a little tick mark. The midpoint of a segment is the point that is splitting a segment into two equal segments. So again, AM here is congruent to MB because they're both 5 units. So M would be the midpoint. And finally, the bisector of a segment is a line, segment, ray, or plane that is intersecting another segment at that segment's midpoint. For example, here, line K is a bisector of segment AB because line K is going through the midpoint P. Plane X is also bisecting segment AB because it's going through P. And segment PQ is also bisecting segment AB because it's going through the midpoint. I'm going to turn the page in your packet and work on the guided practice. Pause your video and come back when you're done to check your answers. All right, so let's take a look at the answers here. For number 1, the distance between the points 3 and 17 would be 14. Between -3 and 17 would be 20. And between -3 and -17 would also be 14. Number 4, we're looking at true or false here. Now, if we've read the directions, it says segment HL and line KT intersect at the midpoint of HL. So that means M is the midpoint of HL. So HM and ML have to be congruent. It does not mean that M is the midpoint of segment KT. Number 4 says ray KT is the same as ray KM. That is true. If you follow ray KT, it goes from all the points from K this way. Ray KM starts at K and follows all the points that way as well. Number 5, segment KT is the same as segment KM. That's false. KM is only this portion, whereas KT is larger. Number 6, ray MT and ray MK are opposite rays. That's true. They both start at the same point and go in opposite directions. 7, line KT is a bisector of segment LH. In the directions, it said that KT and HL are intersecting at the midpoint of HL, so that means it is a bisector. Number 8, the length of KM has to be equal to the length of MT. Now, M is the midpoint of HL, but M is not a midpoint of KT, so that is false. Number 9, if you add TM plus MH, that equals TH. That is false. This looks like it might be the segment addition postulate, but segment addition has to be on one straight segment. Does not curve like this one. And number 10, point M is between points K and T. That is true. They're all on the same line. Number 11, it says to name the point on ray DG, so that starts at D and goes towards G, whose distance from D is 2. So starting at D, going towards G, 2 spaces, 2 would be point F. Number 12 says name the ray opposite ray BE. Ray BE would go this direction. Ray BA would be your opposite ray. Remember, opposite rays have to start at the same point, go in opposite directions. For number 13, it says E is the midpoint of DF. We want to set up an equation to find the value of X. So because E is the midpoint, DE and EF are equal to each other. So we can say 5X plus 3 is equal to 33. And they're equal because E is the midpoint. All right, so we're going to go ahead and subtract 3 from both sides. All right, so we're going to go ahead and subtract 3 from both sides. We'll get 5x equals 30. And when we divide both sides by 5, we would get x equals 6. For number 14, we know GE is equal to y, EH is equal to y minus 1, and the entire segment is 11. This is going to be the segment addition postulate. So we're going to add y plus y minus 1 to equal the entire segment, which is 11. We can combine like terms and get 2y minus 1 equals 11. Add the 1 on both sides to get 2y equals 12, and then y equals 6. And finally, it says find the values of z, GE, and EH and state whether E is the midpoint of segment GH. If GE is now z, EH is now 2z minus 4, and the entire segment is z plus 6. Again, we're using segment addition. Z plus 2z minus 4 equals the entire segment z plus 6. Combining our like terms, we have 3z minus 4 equals z plus 6. We can subtract this z over here and add 4 to both sides to get 2z equals 10. So z is equal to 5. If we plug that back in for GE, GE is equal to Z, so GE is 5. EH would be equal to 2 times 5 minus 4. So EH, that would be 10 minus 4, that would be 6. So EH is 6. So no, E is not the midpoint because one side of the segment is 5 and the other side is 6.